Okay, so let's continue. So this one way to, so this way now I've laid an NMOS transistor. Yeah, and after doing the painting, another thing I noticed here, it's this white dotted shades or area here, and here. So you can just come here. What does it look like? It's telling us, since it's looking like this, so it's telling us there is error somewhere, error here, error here, error here. So to know what the error is, so you can come here and first, you, for instance, you want to know there's error here because you can see it's, before it was green, now it's red. And this, like I said, this is DRC design rule check. So one of the rules has not been obeyed. So, and about 4 of them has not been obeyed. So to know what the rule is really, so maybe for this, or to know what the error is, you can just check them one by one. So for this area, all you just need to do is you place a box around the area, just ensure the box just covers the area. Then you can come to the command console and say DRC, you can say DRC find. I hope that's the command. So that's the command. So DRC find, when you say DRC find, you're telling design rule check to help you look for the error. So well, let's see the results. Oh no. So after, let me make this. So after entering the command DRC find, and it says error area number 2, end diffusion overhang of NMOS is less than 0.23. so this overlap, so it's talking about this end diffusion overlap. This is the end diffusion, right? The overlap is less than 0.23 micrometer. So that is it. That's this extra extra layer of the NMOS, this like this way. It's meant to be greater than 0.23. so let's check. Maybe it's not greater than 0.23, that's why. And I think similarly, I'm very sure that's the same error here. So let's check if it's indeed not up to 0.23. so you can use your grid line to do the measurement. So let's confirm which grid line we're currently on. So it's 0.1. since it did not change when I click on 0.1 micrometer, it didn't change. So each box is the dimension is 0.1. the dimension of each box is 0.1. so if this is 0.1, that means from here to here 0.1, then up to this point it's 0.2. so you can see indeed it is less than 0.23. so what do? You can just increase it more, maybe more than 0.23. so I can maybe just increase it by adding 0.2. so again, look at where the box currently is, and I want the box to cover up to, so I need a box that would start from here and end here. So I'll just position my cursor to the desired up to the desired length, then I right click, so there's a box covering it. Then you can now say paint so end diff, so it paints it green. And you can see when we did that before, it was 4 DRC errors, but now it has reduced to 3. so I'm very sure when we do the same thing for this, it's still going to reduce by 1. so it has reduced by 1. so that means we're clearing the errors now. Then we don't know, so I only assumed since it's, what was here, that was what was here, so I assume it was the same error for this, so that's why I did it. But for this, I can't say what this error is. It's different materials. So again, you try to place the box around, so ensure it just covers the area where the error is showing up. So you right click to resize the box, so at least I have the error area covered. Then I come again and ask DRC. I say DRC find. You can equally say DRC why, like you're asking DRC why, and it's going to tell you the reason. Say poly overhang of transistor is 0.22 micrometer. So again, it needs to overlap more. So it's trying to say this poly only overlapped by 0.2, right? It's not up to 0.22. Look at 1 2. Remember, the dimension of each box is it's 0.2. Sorry, it's 0.1. So that means the overlap is the extra projection of the material away from, remember, this is the N transistor, right? This is the NMOS has been formed. So like the extra projection gives you, that's the overlap they're talking about. So it's saying, the rule says the extra layer must overlap by 0.22, but what we have here is just 0.2. so you can increase the layer again. So let's just say by 1 dimension. So I can just come here and resize the box by right clicking. So then I have up to this, so I can now tell it to paint poly. So then I've done that, and now it's reduced by 1. So I guess also it's the same error here. So I can move this box down here by, after positioning the cursor, then I'll just click the trackpad, or I just left click and it comes down there, and it's the size of the box is exactly the size I want. So I can just go ahead and say paint poly, and you can see we don't have any error again. So now Magic is happy with us, and this whole thing, now we can call this whole thing our NMOS transistor. So you can that's how to do, even if you want to do the layout for PMOS and all. And I know maybe somebody may be wondering now, like, okay, if we have a complex circuit to lay out or to fabricate, then want to do the layout, is this how we're going to be doing? Like, we're going to be laying the materials, the layers one by one, and let's say the complex circuit contains 1000 transistors. So are we going to just be doing this layout 1000 times? Okay, yeah, definitely no, that's not how we're going to be doing it. But I'm just taking us through this so we can relate, coming from device physics, where you've talked about different layers of NMOS, the polysilicon, the N diffusion that forms the drain and the source, and so on. So just to give that basic idea, but of course there is a better way to do the layout, and that's what I'm going to be doing quickly. While I leave this here, I'll just do the second option. So there's a second option. The second option for the layout, it's you just come here. So you want to do the layout for the inverter, right? An inverter just has 2 transistors, 1 NMOS and 1 PMOS, right? So another option is to come generate a PCell, or is it a parametric cell? That's what it's called. So a unit of, so Magic can help you generate unit of those transistors. So instead of you doing the layout, laying the N diffusion, the polysilicon gate, everything, making sure everything forms, we've not even put the N well, the P well. I told you to make an NMOS, you need to put the you need the P well. The P well is a substrate, so we've not added the substrate yet. So how much more now if you try to add the substrate? And you may even get more DRC error, a lot to correct, and all this can take months, as you can see. But thank goodness Magic has an automated option where you can just generate each of the cells. So let's just try something. So we know we need 2 cells, right? We need 1 PMOS, 1 NMOS. So we can just start by generating the NMOS. So you can see, you click, you come here, device 1, you click it, device 1. Then you can see the different devices you can generate. So NMOS, diode, PNP transistor, NPN transistor, PMOS, MOS capacitor, all this you've come across. So but for now we're interested in just generating a cell for PMOS and NMOS. So let's start with the NMOS. So I'll just click on NMOS, and it will bring up this where you need to fill the width, the length, the sizings, and all the multiplicity. M for multiplicity, and fingers for the number of fingers. I would explain this later. Then the device type and so on. So let's not bother about all these things. All we just need to bother about right now is the sizing. So from all we need to do is to go back to our design, this design here. What's the sizing of the NMOS? This is the NMOS. The sizing says 1 micrometer. That's the W/L sizing. It says 1 micrometer to 0.3 micrometer. So I'll just come back, and so the width says what? 1 micrometer. So that's 1. The length says what? 0.3 micrometer. I'll just leave everything as is. I won't touch anything. Okay, maybe I can just click this and just leave the remaining one that way on. So then I'll just press click create and close, or you just do create, but let me just go with this, create and close. So it has created, it has generated it. So but let me zoom out so to see what it has generated clearly, and you can see this. There's a lot to unpack here. So let me move this cell it has generated here so we can see it clearly. And by the way, also notice the DRC error has increased. I think one of the reason is that this newly generated cell is overlapping this thing. So of course that it's trying to check it for you so that you would not go ahead and do your layout, and hopefully you want to fabricate, and is this how you want to fabricate it? So you need to rearrange it. So to move this cell, all I need to do it, so I want to move it, so I'm going to select this. Is now a cell, right? This is a cell. So if you want to select select a cell, unlike a layer that we did, if you want to select a layer, just a layer, you press S on your keyboard. But for a cell, you press the I button on your keyboard, then it gets selected. You can see automatically the command console updated that I selected a cell. So then I want to move it to this point. So as usual, just like your scheme, you press the M button to move. So M for move, and it's now here. And you can see by moving, some DRC errors were reduced. So it was reduced by 4. So you can say one of the errors was a result of overlapping here, which was bad for it, because you don't want to fabricate your transistors like that, overlapping and all. So let me zoom in a little bit, so you can see the newly generated cell. You can still see it's actually our NMOS. Like you can see, look at the green parts. You remember, look at what we created before. Just look at it. Let me bring them side by side. So let me move, so I for select, let me move it up to this point, so M. So you can see basically what we designed. I told you this is basically your NMOS, and that's what is here. So you can see the N diffusion, that's the green layer. You can see it here also. You can see the gate layer, which is red. You can see it here also, and now with some additional stuff. So you by now, I told you any X any symbol, any layer that has this cross sign, it's definitely what is it called, it's definitely a contact. So this is a contact, and you can see some ash shadings all across the cell. That's your N well, like I told you. Sorry, that's your P well. Like I told you, you need a P well. So you see, Magic has a way to relieve the stress for you. You would have added that yourself, but you can see that those slash, or those ash kind of, or not ash, but those shadings that are like slanty to the left. So to confirm that indeed a P well, you just come here, check for P well, look at it, P well. You can see a brown like kind of shade, you know, slanting to the left. That's what you have here. You can see it too. And some other area, you can see the blue color. Yeah, it's a layer also. If you come check here too, just a single blue color. This is it here. You can see this blue kind of brown with brown pattern, something like that. You can see it, that's the metal one. So it has also even done the metal connections for you, so you don't even need to bother. So this, we can say, you can see this method is better than this, so we're definitely not going to be using this for layout. So you can see this would save our time better than this. So this one good way I would recommend when you want to do. So you know, this for the NMOS. If you want to do for the PMOS, let me just zoom out. You'd come here also, just come to device 1 and PMOS. I think our sizing, if you check the design, I think our sizing for this is 3 for the width, and it's the same length for two of them, 0.3. Then I create and close. Now you can see PMOS. Let me adjust this. So I for select, then M for move, I for select, that's if you want to select cells, I for select, then M you position to where you want to move the cell to, then you hit the M button. So you can see this is the width. You can see this is the PMOS, and you can see the PMOS looks bigger than the NMOS, because why? The width of the PMOS is ×3 of the NMOS, so that's why. By the way, this, you know, basically this is the NMOS, right? This portion of it here, and this is the PMOS, this portion of the drawing here. But all around them you have, you know, some materials. So usually that's called a guard ring, the guard ring. So it's like a guard ring, like guarding the NMOS. The reason why it will get clearer as we go on, the same thing, this I've got the guard ring also. So definitely so what have we learned so far? There's a better way of you know, generating our cells, doing the layout. So one way is to use the automated option that Magic gives to you. There's one better way, so we'll talk about that in the next video, even a method better than this. But I can tell you this second method here, where we use this generating the cells individually, it's definitely one of those methods we'll be using. I'll now introduce the third method. So in conclusion, would be using from now on, we'll be using just 2 out of the 3 methods. We're not going to be using this anymore because it can take time, it can waste time. Imagine you have 10 transistors, so just imagine the time it will take to start from here to get to this. So that's why we're not going to be using this method, but we're definitely going to be trying this method, and the third method I'm going to introduce to you. So let me just stop the video here, and we'll see